Alright, hey guys, let's do a little short video on the unit circle and trig things. So we're going to use different identities, I guess, to say if we look at a right triangle, we have something like an angle here, right? Now, we remember that in class we learned that we have SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Then we have its reciprocals, which are cosecant, secant, and cotangent. Alright, so the first thing I'm going to determine is what everything is. Well, if this is my angle, and I'm looking for opposite's directly opposite of it, so this is definitely opposite, right? Then I'm looking for hypotenuse, this is definitely hypotenuse. And lastly, this has to be adjacent. Okay. Alright, so now what I need to do is mark up what sine is. Well, sine is opposite over hypotenuse, so that's 3 over 5. Okay, so that's sine. Cosine is going to be adjacent over hypotenuse, so that's 4 over 5. Tangent is going to be opposite over adjacent, so that's 3 over 4. Right? For cosecant, cosecant is the reciprocal of sine. And I know that it's weird that sine starts with S and cosecant starts with C, cosine starts with C, and secant starts with S. My way of remembering is if you're looking for the reciprocal of S is C, I guess, and the reciprocal of C is S. Right? And then the nice one to remember is tangent and cotangent, because it pretty much screams that it's the reciprocal. Alright, so the sine is 3 over 5, so the cosecant must be the reciprocal 5 over 3. The secant must be the reciprocal of 4 over 5, which is 5 over 4. And the cotangent must be the reciprocal of tangent, which is 4 over 3. Okay. Alright, so that's basically how you have to be able to find like these 6 things for a triangle, given that there's some sort of angle there. Okay, so let's switch this up and let's do something that's unit circle related. Alright, so let's continue with a problem like this. Alright, this is a more common problem, and you'll have to do something like this more often. Alright, so we have a triangle here. It's a right triangle, obviously. Now, we are looking at something that has 30 degrees here, and you can look up across and see that the opposite is 8, and the hypotenuse is x. So the first thing I realized is that, well, if I'm using opposite and hypotenuse, I should be sticking with something with sine. So I'm going to make an equation with sine. So it's going to be sine of 30 degrees is equal to opposite over hypotenuse, so it should be 8 over x. Okay. Alright, so I've set up the equation, and this is where the unit circle comes into play. Things like 30, 60, 90, all of those angles, any increment of 30, they can be determined by your unit circle. So we're going to take a look at the unit circle, and I see that at 30 degrees right here, it's also known as pi over 6, or a sixth of a radian. I have this coordinate, square root of 3 over 2 and half. Now the way that you're supposed to read the unit circle is that for 30 degrees, the cosine of 30 degrees is square root of 3 over 2. This is the cosine. Okay, so the cosine of 30 degrees is square root of 3 over 2, which means that the sine of 30 degrees is 1 over 2. Now what if you were to find the tangent? And this is what we talked about in class. If you were to find the tangent, you need to do sine over cosine. Sine over cosine. Okay, so let's go ahead and plug this in. Okay, so sine of 30 degrees, looking at the unit circle, is 1/2. So we know that this is the same thing as 1/2 is equal to 8 over x. So I'm just going to multiply both sides by x. I get 1/2 x. 1/2 x equals 8. From there I'm going to multiply both sides by 2, and I get x equals 16. So I know the length of this hypotenuse now. It's 16. Right? Now, what if I said find the last length of this? Well, you should be able to do that in two different ways. You could do the Pythagorean theorem, or you could use, well, let's see, we would have to use adjacent here. And we could use adjacent and opposite using tangent, or we could use, now that we have the hypotenuse, cosine is adjacent over hypotenuse. Alright, so that's how you would use the unit circle. Remember that the unit circle is always in the form of cosine, comma, sine. Okay? And it just essentially is a chart that gives you all the sine, cosines of 30, 60, 90, 120, 150, 180, all the increments of 30 degrees. Okay? Alright. Hope that helps.